Chapter 1, Section 2. We're going to skip Section 1. We're going to go straight to Section 2. This is called real number properties. The goal of the lesson is by the end of this lesson, students will be able to recognize the difference between each of the 6 axioms of real numbers and successfully match an axiom with a mathematical expression or equation. Basically, we're going to review the properties that you've seen for quite some time, and we're going to practice them. And when you see them, you'll probably remember most of them. All right, an axiom, first of all, when you hear this, an axiom is just a statement that is accepted to be true without proof. Okay, a statement that's accepted to be true without proof. So given these following things, A, B, and C denote any real number, the following would be true. The closure of addition and multiplication. Basically, this is just a rule in math that we assume to be true. If you add a whole number to a whole number, which is what this is saying right here, I'm adding a whole number to a whole number, A plus B, my answer is going to be, is it possible for me to add a whole number to a whole number and get a fraction or a rational number? No. So A plus B, if it's whole, I'm going to get also C, which is a whole number as well. A times B, so if I multiply 4 times another whole number 2, is it possible for me to get a fraction? The answer is no. So addition and multiplication stay within their own little world. If you get into division and subtraction, it can be different, but addition and multiplication have a closure. If you add a fraction to a fraction, the answer is going to be a fraction. If you add a integer to an integer, the answer is going to be an integer. That's what closure means. Associative property of addition and multiplication. Okay, this one has to do with the parentheses. So anytime you see associative, think of the parentheses or the grouping. Sorry about my messy writing there. But we're going to think about parentheses. Okay, A plus B plus C equals A plus B plus C. What that means is it doesn't matter which ones I add together first, I'm still going to get the same solution, the same answer. So, for example, 2 plus 3 plus 4, if I add 3 and 4 and get 7 and then add 2, which gives me 9, it's the same thing as adding 2 plus 3 first and then adding 4. 2 plus 3 is 5, 5 plus 4 is 9. So we get the same answer both ways. The same thing is true for multiplication. You can multiply in any order. And you probably know that. What you don't remember is actually what it's called. You know that you can add numbers together in any order and you can multiply numbers together in any order, but what you probably forget is that it's called the associative property of either addition or multiplication. That's what I want you to remember, okay, is try to get those two and remember that. Now, commutative property of addition and multiplication. Commutative property, this you also probably already know, but what you don't know is what it's called, okay? So A plus B equals B plus A. You know that if I take 2 plus 5, it's going to give me also the same answer as 5 plus 2. What we call that is the commutative property of addition. Same thing if we're doing multiplication. A times B is equal to B times A. For example, 2 times 5 is 10, 5 times 2 is 10. Those are called commutative. You know the property that you can do in math, you know this, but what you probably don't remember is that it's called commutative. So that's what I want you to remember, is that when you have two numbers, no matter what order you multiply them, it's called the commutative property of multiplication, and then if it's addition, the commutative property of addition. The distributive property, everybody who's seen this one, it's when the A jumps the parentheses to get rid of the parentheses. A times B plus A times C. Same thing can be true, and you might not know this one. If it's the other way around, okay, all we did was switch the order of multiplication, which we know is commutative property, but I can also jump backwards, A times B plus A times C. You might not know that, so that's important to know there. if you want to see it done with an example, if I have 2 times x plus 3, if I jump the parentheses, I get 2 times x, or 2x, plus 2 times 3, which is 6. And it can also be done backwards. If the 2 were in the end, you could do it the other way. Identity of addition and multiplication. This is another one you've probably seen. You just didn't know that there was an actual axiom or name in math that we stick to this. So, a plus 0. We know anything plus 0 gives me just whatever we had. It doesn't change anything. But what we call that is the identity property of addition. Identity property of addition. When we add something to it, you get the same thing back. It doesn't change anything. We call that identity. Same thing with multiplication. A times 1 gives me A. No matter what I put in there for A, no matter what number I replace A with, I still get just that number. It doesn't actually change the value of the number. So we call that the identity property of multiplication. Excuse me. Now, the additive and multiplicative inverses. This is, what do you do to a number? And we just did this when we solved equations. What did we do to one side of the equation to get the variable by itself? We do the opposite, or the inverse operation. You just did that, okay? When I have an inverse, which is what we do when we solve equations, we get 0, and that's called the additive inverse. Now, multiplicative inverse must have disappeared, but the multiplicative inverse looks like this. A times 1 over A equals 1. When you get the number 1 back, that kind of looks like a 9. I apologize. My writing is a little ugly. Oops. Erase. There we go. That looks a little more like an A. So this is the additive and multiplicative inverse. The additive inverse, when we add A plus the opposite, it gives me 0. Multiplicative A times 1 over A gives me 1. Here are some things to look for. That's all the axioms or properties I'm going to give you. I'm going to give you some hints on how to do the worksheet and what the right answers are. So whenever you see an expression that has the phrase is a whole number in it, we know it's going to be the closure property. And I'll show you an example of that in a little bit. But what you remember is that if you see the words is a whole number, or is an integer, or is a rational number, or whatever, you know it's going to be closure property. Another hint, the associative property, the order stays the same. If the order changes, it's most likely commutative property. But if the order stays the same, but the parentheses change, it's associative property. Okay, commutative property, the parentheses stay the same, but the order changes. If you see a 1 or a 0 in the statement, it's either the inverse property or the identity property, and all you have to do is decide which one. So using these hints, I'm going to do 3 or 4 examples for you that are going to be similar to what you're going to see on your worksheet. So let's go ahead and go through that. So given this equation, I have to decide what property tells me that this is true. Well, I have 8 times D times R, but here I want to multiply D times R first. Okay, and the next one, 8 times D times R, here I want to multiply 8 times D first. Now let's think to ourselves, all right, back to those hints. Okay, and if you have those hints in front of you, that's great, maybe write them down. But when I look at that example, okay, does the order change or does it stay the same? Well, 8, D, and R are in the same order on both of those. So let's think about that. Since the order stays the same, does do the parentheses change? They do. So we would say this is the associative property of, is this addition or multiplication? It's multiplication. I'm on a delay a little bit, I apologize. All right, let's do another example. Now, w plus 9 is a real number when w is in the set of all real numbers. So what they're saying, if w is a real number right here, that means w plus 9 is a real number. And remember that hint I gave you that says if you see the words is a blank number, it's got to be the closure property, and that's what this is. Do you see how it says is a real number? That's one of the hints I gave you. As soon as you see that wording, you know this is the closure property. Okay, I'm not going to write a property because I'm in such a delay. Now, 4 times 1/4 equals 1. Notice how you see the number 1 equals 1? Well, if you remember back to your properties, 4 times 1/4. Where did we see that? We saw a times 1 over a. But this time, a stands for 4. We used the value 4. So this is going to be the inverse property of multiplication. So we would say inverse of multiplication. Now, 12 times p plus 3h plus 0 equals 12p plus 3h. Now, notice we have a plus 0. We also have parentheses and we also have some addition, but the order doesn't change. And what else doesn't change is I see the parentheses here are still making me add the same things. Here I'm adding 12p plus 3h, and here I'm adding 12p plus 3h. That's not changing. So what is changing from this one to this one? That's the property we're looking for. So what is changing is on this one, there's no plus 0. Well, what property did we have on that list of properties that had a plus 0? It was the identity of addition. And I'm going to abbreviate since I'm on a delay. Those are the examples that I have for you. What I want you to do is there are worksheet 1. Go ahead and get that done. Finish it. What I want you to try to do is get at least 60% of them correct. So go for 50 to 60%, and then we will keep practicing these throughout.